Triton is not just another frozen rock drifting quietly in the outer solar system. It is one of the strangest, most hostile, and most scientifically fascinating moons ever discovered. Orbiting Neptune in defiance of nearly every rule moons usually follow, Triton behaves like a captured outsider, cold, volatile, and full of unsettling surprises. Spending just 5 seconds on its surface would not be a heroic achievement. It would be a race against physics itself, and one you would almost certainly lose. This video explores what Triton really is, how it came to exist in its bizarre state, and exactly what would happen to a human foolish enough to step onto its surface, even for a moment. The facts are real, the science is sound, and the danger is absolute, all paraphrased and synthesized from the provided source material. A moon that shouldn't exist the way it does. Triton is Neptune's largest moon and dominates its planetary system so completely that it accounts for nearly all the mass of Neptune's moons combined. With a diameter of about 2,700 kilometers, Triton is slightly smaller than Earth's moon, but larger than several dwarf planets, including Pluto. That alone makes it noteworthy. What truly sets Triton apart, however, is how it moves. Unlike most large moons, Triton orbits its planet backward. This retrograde orbit is a cosmic red flag. Moons generally form from the same disk of material as their planets, which means they orbit in the same direction their planet spins. Triton does the opposite. Its orbit is also steeply tilted, almost upside down compared to Neptune's equator. Together, these clues strongly suggest that Triton did not form alongside Neptune at all. Scientists believe Triton was once a free-roaming object from the Kuiper Belt, a distant region filled with icy remnants from the solar system's formation. Billions of years ago, Neptune's gravity captured Triton, dragging it into orbit. That violent arrival likely destroyed or ejected many of Neptune's original moons, earning Triton a reputation as a kind of cosmic wrecking ball, a surface carved by ice and violence. At first glance, Triton looks smooth and deceptively calm. In reality, its surface tells a story of constant renewal and geological unrest. The ground is composed largely of frozen nitrogen, water ice, and methane, locked in place at temperatures so low they barely exist above absolute zero. The average surface temperature hovers around -235 degrees Celsius, making Triton one of the coldest known objects in the solar system. Despite this extreme cold, Triton is geologically active. Instead of molten rock volcanoes like those on Earth, Triton hosts cryovolcanoes, ice volcanoes that erupt slushy mixtures of frozen nitrogen and water. These eruptions can shoot plumes several kilometers into the thin atmosphere before the material falls back to the surface like frozen ash. One of Triton's most famous features is its so-called cantaloupe terrain, named because its surface resembles the dimpled skin of a melon. This landscape stretches for thousands of kilometers and is believed to be the result of repeated cycles of freezing, cracking, and refreezing. It is alien, unsettling, and unlike anything found on Earth. A thin atmosphere that can still kill you. Triton technically has an atmosphere, but calling it breathable would be wildly misleading. It is about 70,000 times thinner than Earth's atmosphere and composed mostly of nitrogen, with trace amounts of methane and carbon monoxide. Much of it comes from gases released by cryovolcanic plumes. This thin atmosphere creates one of Triton's deadliest hazards. If a human were to remove their helmet on Triton's surface, the lack of pressure would cause bodily fluids, saliva, tears, moisture in the skin, to begin boiling instantly. This would happen even though the environment is unimaginably cold. The body would experience explosive decompression, causing lung damage and loss of consciousness in seconds. In short, Triton manages to combine the worst of both extremes, freezing temperatures and vacuum-like pressure. It is cold enough to freeze you solid and empty enough to tear you apart from the inside. Gravity that won't save you. Triton's gravity is only about 8% of Earth's. That might sound like a relief, but it introduces another deadly problem. Movement becomes unpredictable. A misjudged step, a small jump, or a slip near one of Triton's many fractures could send you drifting uncontrollably across the surface or tumbling into an icy chasm. With no thick atmosphere to slow your fall and no strong gravity to anchor you, regaining control would be nearly impossible. Triton's surface is riddled with cracks, unstable ice sheets, and regions weakened by cryovolcanic activity. Standing still is dangerous, moving is worse. What lies beneath the ice? As hostile as Triton's surface is, its interior may be far more intriguing. Beneath its thick, icy shell, scientists believe Triton may contain a layered structure, a metallic core, a rocky mantle, and potentially a subsurface ocean of liquid water. This ocean could exist because radioactive heating in Triton's core may provide just enough warmth to keep water from freezing solid. If such an ocean exists and comes into contact with rocky material, it could create the chemical conditions necessary for life. Carbon, hydrogen, nitrogen, and energy sources could mix in ways similar to environments on Earth that support microbes. No one knows if life exists there, but Triton is considered one of the more promising places to search beyond Earth. Ironically, the same moon that would kill a human almost instantly on its surface could potentially shelter life deep below its ice. Humanity's only glimpse so far. Despite its scientific importance, Triton has been visited only once, and even that encounter was brief. In 1989, Voyager 2 conducted a historic flyby of Neptune and its largest moon, capturing images from tens of thousands of kilometers away. During that short window, Voyager 2 managed to photograph roughly 40% of Triton's surface, before continuing its journey toward interstellar space. It was humanity's first and only direct look at this distant world, and it came at a time when imaging technology was far more limited than it is today. Even so, those images reshaped planetary science. Scientists saw active cryovolcanoes, nitrogen plumes rising into a thin atmosphere, and a surface that appeared surprisingly young and constantly renewed. Triton was no longer just a frozen relic. It was alive with internal energy. Yet more than half the moon remains unseen, and no spacecraft has returned to fill in the gaps. As a result, much of what we believe about Triton today still relies on indirect measurements, modeling, and comparison with similar icy worlds rather than direct observation. 5 seconds that change everything? So what would actually happen if a human attempted to spend 5 seconds on Triton? The moment you stepped outside a spacecraft, survival would become a countdown. The near vacuum atmosphere would cause an immediate and violent drop in pressure, triggering rapid decompression. Bodily fluids would begin to boil, even as the surface temperature plunged your skin toward instant freezing. Breathing would be impossible, and the lungs would fail within seconds. Consciousness would fade in well under 15 seconds, long before hypothermia even had time to fully take effect. Weak gravity would make it difficult to stay grounded, and the fractured, unstable ice beneath your feet could give way without warning. In theory, 5 seconds might be enough to touch the surface or plant a symbolic flag. In reality, it would be nowhere near enough time to escape alive. Why Triton still matters. Triton is undeniably lethal to humans, but that danger is not what makes it important. Its value lies in what it reveals about the solar system's past and its hidden possibilities. Triton challenges long-held assumptions about how moons form, showing that captured worlds can remain active for billions of years. Its unusual orbit, dynamic surface, and potential subsurface ocean force scientists to rethink where geological energy and even life might exist. If humanity ever returns to Triton, it will not be for dramatic landings or human footprints. It will be through carefully designed robotic missions, orbiters, and probes, capable of drilling through ice and sampling its interior. Triton does not reward speed, bravery, or spectacle. It rewards patience, precision, and understanding. And that is exactly why it remains one of the most compelling destinations in the outer solar system. If you enjoyed exploring the most dangerous moons in the solar system and uncovering what science really says about worlds like Triton, make sure you like and subscribe. If you want to be smarter every day, like and subscribe, because the cosmos always has another story waiting.